Hello everyone, my name is Harsh and this is my final project submission for CS50 Introduction to Databases. This is my project and if I open it up, you can see the design part. Now what is the purpose of my database? My database, it is for a wellness cafe in which I am creating a database from the scratch of a cafe. What all things are going to be inside it? There has to be few tables, and these tables are named as cafe locations, employees, cities, roles, cafe financials, and you can clearly see there are so many of the tables out there. If I give you the perfect outcome, it would be around 16 to 17 tables. I have also mentioned few important things like what are the things that are outside the scope of my databases. That means I haven't uploaded the predictive analysis, the employee certifications in this, the loyalty program, nutritional information of the recipe of the management. I have not included all these things in my database. These are things that are outside my database requirements. Now the next thing comes that what our user should be able to do with the database. Everything when it comes to user management, financial management, order management, product management, inventory management, feedback management, and all the things. A user would be able to deal with all those things when it comes to my database. What's beyond the scope of my database, I have mentioned. The next thing comes that what is the entity, the representation, and that means our database is now been done. When it comes to table, what all entities I have added on those tables to make it suitable for my database or for my project. That means a city ID, phone number when it comes to a table of cafe locations. It will be much clearer when I show you the database. I'll show it to you. For example, wait a minute. Here, if I show it to you, my database in PHP Lite Admin, and I open a table called customers, for example, you can clearly see that my customers table has this many columns: ID, first name, last name, gender, address, email, phone number, membership, all these things. So when it comes to all the tables, I have mentioned all the entities here briefly so that a user would be able to understand it. For example, I open the table of customers. You can clearly see that this is an ID. ID what? It specifies a unique identifier for each customer as an integer. That means it's a unique key or a primary key. This column has a primary key constant applied, and that is an auto increment keyword also applies. The first name, the last name, the gender, email, phone number, and all the columns are required. That means a not null constant is applied. That means all the columns have to have a value. You cannot have a null value on these tables. So this is my database. My database also have some tables, some view tables as well. I'll come again to this view table in a few after slides. After that, I open my entity relationship diagram for you. So this is my ER diagram. As you can clearly see that there are so many tables out here and all the tables are related to each other. That means there are some unique key and there are some foreign keys. I have also made the relationship here, which would be easier for me to join the table in the future to run out the queries, which we want to take the result out of the database. This is my ER diagram. Now next thing comes as a schema. Very important thing. So for my schema, I'll show it to you. My schema is very intense. So basically it says that in my schema I have made the tables. For example, when it comes to the table, for example, this cafe locations table, I'll show it to you by, for example, the cafe locations. If I open this table, you will have a better understanding of it. My cafe locations table, this is the basic sentence of how you create a table. Create a table and then you just define all the things. So create table, my table is ID, and then there's a name, city ID, address, phone number, email, total employees, opening date, closing time, and closing date. So all these things, and these are the constants which I applied. For example, for the ID, there's an integer, name is the text, city ID, it's a foreign key. That means there's another table named as cities, and there will be an ID, and it will link to it. Okay, as you can see also here, if I open my table, I'll show it to you. First one, I'll show it to you. Address, the text is null. Phone number, email, total employees, and this. And then after that, I have defined my ID as a primary key and the foreign key, which references to the cities table in the ID. Okay, and this is how I made all the tables. For example, ID when it comes to the table of products, ID, product name, price, category, and primary key. This is the syntax of how you write a table, create a table. And after creating the table, that the next step was to insert the data into that. This is the basic syntax of how you insert a data into a table. Insert into the table name and the columns in which you are adding the things. Okay, for example, if I open the table of cities, you can see here that this is the syntax, the ID, the name, and the state. And this is what I have added: Delhi, 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 Mumbai, Maharashtra, Mumbai, and Maharashtra. So this format is a CSV file. CSV, that is a comma separated value format file. So I have added all these things into my table. I have done the same things for all the tables when it comes to cafe locations, when it comes to suppliers, raw materials, and when it comes to employee. The data looks huge, and it was a difficult task to insert the data as well. But this table is not, but this database is not very data intensive. But even after it's not that data intensive, I have also added few other things. That is what I call as index. I'll first explain it to you what a view is, and then I'll come back to the index. For a view, for example, if I have to write a query to know which customers, how many customers, total number of orders, and total amount of they spent. If I want to summarize these things, so for that I have to write this query and I have to run it. What if I have, after one day, I have to write this query again? So I have to see that again. So for that I have to run that query again. And to break down this task of doing this manually and writing all these queries one by one again to just have a same outcome, we just do a shortcut and we just create a view. So next time, whenever I want to see this thing, I do not need to type all this query again. I just need to type this and my answer will come. For example, I'll show it to you. If I open this project in an integrated terminal, and then here if I type SQLite 3 final project.db, and if I click enter, Control L, and for example, if I tell you that I want to see view to summarize each customer's total number of orders or total amount spent. If I haven't created the view, I had to run this query and this is the answer. But if I have to see it again after some day, I just created a view. So next time I just do one thing, I just select all from customer order summary. That's it. I don't have to write anything extra, just this, copy and paste, select all from customer order summary, and the answer is Control L. Can you see? The answer is here. Without even writing all the things, this is what a view is. Okay, so next thing, I have created view for all these other tables. For example, all these things I have created view, and then after creating the view, I have created few indexes as well. What an index basically does, it basically lowers the time. So currently for my database, this is not important, but when it comes to a database which has millions and millions of rows and tables, it would be very difficult for a user to write a query and find out the data because of the running time. The time would be higher and we don't want that. And for that we create an index. Index is basically a shortcut of how you can find a data or a value in your database. Okay, and for that I have created indexes. And after that indexes, I'll show you the queries which I have run, and all the queries are giving the correct answer. For example, if I want to see the first name and last name and email of the customer of all the females, the gender here has to be female. If I create this, Control L, and I paste. This is the answer. How can we verify if the answer is coming correct or not? I just go to my customers table and see that the first female is Ishita Verma. First female is Ishita Verma, and my answer is coming up as Ishita Verma, and this is the email ID of that. And I have wrote few queries about that. For example, some are simple queries in which there is only where clause and how clause and order clause, and some queries are difficult. For example, in which I have made a use of joins, and this is a join. For example, if I wanted to know that, write a query to get the first name, last name, and the product name of all the customers who have placed orders, include the cafe location's name and where the order was placed. You can clearly see that I have to join different tables to get the outcome of this query. So I have to join customers table, orders, cafe location, ordered products, and products. And by joining all these tables together, I will get the answer. So for example, if I select it, go here, Control L, and I place this is the answer. So the relationship between the tables is also working fine. The queries are perfectly working, and this is my final submission for that. Thank you so much.